You should prove this statement by mathematical induction. Now, I've done one example already, and we looked at the reasoning behind mathematical induction. What I want you to do right now is pause the video and work this one out. Then come back to the video and watch the rest of it. Okay, have you paused the video and proved this statement by mathematical induction? Let's see. So here now, we have 1 plus 2 plus 3 plus that plus n is equal to n plus 1 divided by 2. So what this is saying, before we start, let's just clarify something. When you have P1, P1 means 1, n is 1, right? Now, what this means, is the proposition you're looking at. Pn is n plus 1 divided by 2. So P1 is 1 plus 1 divided by 2. So what you have is 2 divided by 2 is 1. So P1 is true, because we have 1 here. That applies to the first term, the term in position 1. If you want to show that P2 is true, no problem. The term in position 2. When you do it, you're supposed to get 3, because 1 plus 2 is equal to 3. Let's see. P2, you expect to get 3. Let's see. P2 means 2, n is 2. 2 plus 1 divided by 2. So it's 2 times 2 ones 2 divided by 2. So, no, 2 plus 1 is 3, divided by 2. Well, you could just cancel out and get 3. Suppose you consider P3. P3 should be 3 plus 2, 5 and 1, 6. It should be 6. Let's see. P3 is equal to 3 plus 1 divided by 2. 3 and 1 is 4. 4 3 is 12 divided by 2 is 6. Good. What do you think P4 would be? Well, P4 should be 4 plus 3 plus 2 plus 1. 4 plus 3 is 7, plus 2, 8, 9, and 1, 10. It should be 10. Let's see if that is so. 4 plus 1 divided by 2. 4 plus 1 is 5. 4 times 5 divided by 2. 4, 5, 20 divided by 2 is 10. So you would get 10. Alright, fair enough. So, we proved this for the first 4 terms. But you only need to prove it for the first term 1. You only need to prove it for that first term. Now, we assume that this statement is true for the kth term. You don't know what that is, you don't specify. You just term k. Maybe k is 2, no problem. So if you should prove that P1 is true, you'll also prove that P2 is true. If you imagine that k is 2, but how do you know that the next term would be true? That's what we're coming to. So assume pk is true, right? Now, if pk is true, then what it would mean is that 1 plus 2 plus 3 plus that plus k, where n would be k, you stop at k, whatever k is, and that would be equal to k plus 1 divided by 2 is true. Alright. Now, if you prove that P1 is true, then you started the process, right? You got it right from the start. You show that pk is true, where k is any number. But how do you know that it is also true for the number after k, right? If k is 2, then you show that p1 is true, then p2 is true. How do you know that p3 is true? If k is 30, then you would show that p1 is true, p30 is true. Question is, how do you know that p31 is true? So we need to prove that the statement is true for the term after k. So what we need to do now is prove that pk plus 1 is true. So what we have now is 1 plus 2 plus 3 plus dot 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 plus k plus, after we reach k, we go to the next term, which is k plus 1. That is equal to now. Now remember, we're going to replace k with k plus 1. So this k plus 1 times, this bracket is going to come here now, open bracket. This k is replaced by k plus 1, so it's k plus 1. Let's put it in its own bracket. Alright, this, this k is this k plus 1. Then this plus, and then this 1. And then all of this over 2. We're going to prove that that is true. Alright? What did I write up here? THAT. Alright. So now, hold on. Let's see something here. Look at this part. Does it look familiar? It is this, which is the same thing as this. No, yeah, same thing as that. So we can just rewrite that and say we have k plus 1 divided by 2. It is this. Oh no, let me redo that. It is this. Alright, that's it. Then plus this now, this k plus 1 equals, and then all of this k plus 1, well, this bracket and this, we won't need those brackets. They would make a difference, so we can remove them. K plus 1 divided by 2. Alright? So, what happens now? We want to prove that one side is equal to the next. So let's continue. This is, let's multiply these out. K squared plus k divided by 2 plus k plus 1 equals k plus 1 bracket k plus 2 divided by 2. Alright, so have these things divided by 2. Let's use common denominators. This will be over 1. Let's multiply the denominator by 2, but we must also multiply the numerator by 2. So what we have is k squared plus k divided by 2 plus. This is 2, k plus 1 divided by 2 is equal to that, right? K plus 1, k plus 2 divided by 2. And by the way, remember, if you had started working it out and got stuck somewhere, once you see me reach that point, pause the video and finish it off. So if you didn't manage to work out the entire proof. I want you to continue from here. In fact, you should continue from wherever you might have reached. Or if you followed and you understood and reach a certain step, then pause the video and finish it off. You learn by doing, alright? And you must practice. Alright, so here now. This part, what is it? We can write this as k squared plus k plus 2, k plus 1, all over 2. Remember your fractions, right? Equal k plus 1, k plus 2 over 2. So what happened here now? This is k squared plus k plus 2 times k plus 2 times 1, which is 2 over 2. And that's equal to k plus 1, k plus 2 divided by 2. Alright, let's hold on. Let me see something here. This part over 2. Suppose you factorize this. It's like a quadratic equation that is partially factorized already, you know. Let me see something. In fact, I could have just factorized from up here. Look at this. Hold on. If I look back at this part here, I realize I could take a common factor out of the bracket for k squared plus k. So I have k and k plus 1. Right, plus 2k plus 1. I was thinking of making a quadratic equation and then factorizing it, but I will go right back to this point. So I could just factorize this part. And what I would have, look at this. This k plus 1. K plus 1 is a common factor, you know. So I'll put k plus 1. Once you remember your factorization of quadratic equation, you would understand what's going on here. Then open bracket, k plus 2. There's k plus 2. That divided by 2 equals, oh boy, this should be k plus 2, right, divided by 2 equal. This one is k plus 1, k plus 2 divided by 2. So, the left hand side equal the right hand side. It is proved. So, let's just review what went on. So, we're given the statement 1 plus 2 plus 3 plus that plus n equal n plus 1 divided by 2 to prove by induction. That's mathematical induction. Now, this statement for n is n plus 1 divided by 2. So for 1, it's just 1 is equal to P1 is 1 is equal to 1 times 1 plus 1 divided by 2, which turns out to be 1. Okay, good. So therefore P1 is true. You assume that Pk is true. Is some value k for n. So you substitute k for n. So 1 plus 2 plus 3 plus and so on plus k is equal to k plus 1 over 2. And of course, you may be saying, why is it that I change n to k? It's because n could be 100, right? Or whatever value. K is a number less than 100. It can be any number. Because if you prove that it is true for P1, and you prove that it is true for P100, you don't know whether it is true for P50. So you must fill in all the terms between 1 and 100. Although n do, you know, it goes on and on, there's no end to it. So we want to identify numbers, but k is a number that we don't specify. We know we prove for 1, but k can be any number. You could prove for 2, but you don't prove for 3, and so on. So k could be 4. You prove for 1, but you don't prove for 2. K could be 2, whatever number it is. So here now, 1 plus 2 plus 3 plus that plus k equal k plus 1 divided by 2. That is true. Now, whatever k is, question, what about the number that follows k, the number after k? Well, the number after k is k plus 1, whatever k is. So you must prove that p of k plus 1 is true. So 1 plus 2 plus 3 plus up to k plus the next number after k is k plus 1. It is equal to, so we change k to k plus 1. And then we recognize that the 1 plus 2 plus 3 plus that plus k, it looks familiar, we've seen it before. It is this. It is the same 1 plus 2 plus 3 plus that plus k. And that is equal to k plus 1 divided by 2. So we write this as k plus 1 divided by 2. And then this part, we add it, and that is equal to, and simplify this. Then after that, we use common denominators from our knowledge of adding fractions. Put this over 2, then recognize that we could just, we have all of this over 2, we could just factorize and get k plus 1, k plus 2 divided by 2 equal to the same thing on the right hand side that says k plus 1, k plus 2 divided by 2. And that's, the statement is proven. So that is it for now. I will see you in the next video.